Good day, everyone. We are Group 2, and today we will be presenting our peer assessment critique of a traditional assessment instrument created for a Grade 7 Information Technology class. My name is Ashanti Anderson, and I will be leading the presentation today. Joining me are my colleagues Kristen Sewell, Casey Granell, and Sienna Powell. This critique required us to assume the roles of an assessment review committee. Our task was to evaluate the quality, alignment, cognitive rigor, and the overall effectiveness of an instrument designed for the topic Foundations of Hardware and Software. We grounded our analysis in assessment principles taken from Nick Cohen Brookhart, Guan and Lim, and amongst many others. Our goal was to provide a fair, evidence based critique that highlights both strengths and areas that need improvements. To begin our detailed evaluation, I will now hand over to Kristen, who will outline the purpose of the critique and introduce the instrument. Go. This critique required us to assume the roles of an assessment review committee. Our task was to evaluate the quality, alignment, cognitive rigor.
Thank you, Ashanti. The purpose of our critique was to determine whether this traditional test meets the qualities of good assessment, including reliability, validity, fairness, and cognitive balance. So we reviewed the structure, item quality, alignment with the objectives, and overall presentation of the test. Now, here's a brief overview of the instrument we examined. So this instrument consisted of 70 marks and used four question types: multiple choice, matching, short answer, and one essay question. The instrument is intended to measure foundational information technology for grade 7 students, and the test was set to last 1 hour and 30 minutes. Now, before we go forward, we'd like to share the content that guided this critique. So, we looked for the item quality and guidelines for item construction, the alignment between the instruction and the unit's objectives, the domains of learning, the DOK levels targeted. We also looked at grammar and mechanics, and finally, recommendations for improvement, which was supported with academic literature.
Thank you, Kristen. So now we'll be looking at item quality and guidelines for item construction. So in terms of strength, the instrument shows good coverage of the topic. The questions effectively assess key objectives such as defining hardware and software, distinguishing data from information, classifying devices and identifying the functions of different types of softwares, which in fact this demonstrated solid alignment between the items and what students are expected to learn. Next, the questions are basically straightforward and unambiguous, which minimize, students' confusions and so on. Another strength is the mild use of conceptualization. So several items, especially questions 1 and 8 through to 10, presented realistic and relatable scenarios. So these help students connect theoretical concepts to real life situations, which increases engagement and supports deeper understanding. Another important strength is the presence of plausible distractors in several of the multiple choice items. So in questions 3, 5, and 9, the distractors are not just random. They reflect common misconceptions students often have about hardware, data processing, and device classifications. So this is valuable because it allows the assessment to function diagnostically. So it helps teachers identify specific misunderstandings, not just whether or not a student got the item, wrong or right. Additionally, the instruments demonstrate strong content validity. So the correct answers presented in questions 1, 3, 4, 7, and 10 are grounded in widely accepted definitions and fundamental computing principles. So this ensures that the students are being assessed on essential, accurate, and reliable concepts within the topic of hardware, software, and basic ICT, foundations.
Still continuing with item quality and guidelines for item construction, we will now look at the weaknesses of the multiple choice questions that we examined. Now, there were questions where several distractors were too obvious, implausible, or unrelated, reducing the question's ability to differentiate between levels of understanding. The questions that we identified were questions 2, 4, 6, 9, and 10. And there were certain items that introduced terms or comparisons that may have misled less experienced students. And we saw this in question 7 and 10. And here's an example of question 7 where we see which statement best explains the interdependence between hardware and software. And the identified was A, hardware can function without software, and C, hardware and software do not interact. Continuing with multiple choice weaknesses, we could also see that some questions could better test partial knowledge or deeper thinking. So, like question two, which had distractors C and D that were far from the concept of system software, and we see where that limited the challenge for students with partial understanding. Because, as you can see, the question, which of the following best describes system software? And the distractors that we selected, C and D, says type of hardware that stores data permanently, or a device that allows users to input data into the computer. So we identify those as being far from the concept of system software. Similarly, we reviewed the matching activity and we saw that there was a clear alignment with the objective, and we identified this as a strength of this activity. So all items directly assess the definitions of fundamental terms, hardware, software, data, computer, etc., which aligns well with objective one. And objective one states that they are defining the terms computer, hardware, software, etc. And then there was the straightforward structure. So we identified that the format was well structured and organized for students to follow, because each term in column A, as you can see, corresponds with a commonly accepted textbook definition in column B. There was also balanced cognitive demand. So the task focuses on basic recall and recognition of definitions, which is appropriate for early units or introductory lessons in information technology. We also identified that there was no ambiguity in the correct answers. So each definition is distinct, reducing the likelihood of confusion or overlap between items.
Now we will speak about the weaknesses of this test. So some weaknesses that were shown were for the matching items aspect and also the essay question. The matching items lack a consistent logical order, which may increase cognitive load. The essay question had a high writing demand, extended text, grammar, organization. This may disadvantage students with weaker literacy skills, even when their IT knowledge is strong.
Thank you. So now we're going to move on to alignment with objectives. As you all know, alignment checks whether the test accurately measures the objectives outlined in the unit and also the table of specification. Our group went ahead and analyzed each items to see how well it matched the intended learning outcomes. So on the screen right here, we have a table with examples of the objectives and the items that were related to each, and I'm going to go ahead and go through them. So objective one was to define key item terms. This was shown in question 1 and 2 for the in the multiple choice section, and this was at the appropriate cognitive level. Objective number 2, to differentiate hardware versus software. This was shown in the short answer slash essay questions. This was good coverage of conceptual understanding. And for objective number 3 was to classify devices. And this was shown in multiple choice questions 5 and 6. This aligns with classification skills, but it also lacks real world application. The last objective was to demonstrate practical skills. This was not fully assessed in any of the questions, multiple choice or essay. Psychomotor objectives are only assessed in the alternative sections. Thank you. So now we're going to move on to alignment with objectives. As you all know, alignment checks whether the test accurately measures the objectives outlined in the unit and also the table of specification. Our group went ahead and analyzed each items to see how well it matched the intended learning outcomes. So on the screen right here,
Thank
we
you.
have
So, the assessment demonstrates strong alignment with the unit's objectives in several ways. So, for example, key concepts such as defining computer, hardware, and software are directly assessed through multiple choice items. Another strength was the fact that the test progressed from simple recall to application questions, reflecting Anderson's and Crowthwell's 2001 cognitive framework. And this showed alignment with the grade 7 IT curriculum, which supports content validity. The assessment also had, several weaknesses. One being most items focused solely on recall, with few addressing higher order thinking, and only the essay question really targeted, analysis or problem solving. Three, it evaluates only cognitive skills, neglecting psychomotor and affective domains, which are really important for IT, right? And lastly, the mark distribution does not align with the table of specification.
This slide looks at the means of learning and cognitive rigor by using the depth of knowledge or DOK levels. DOK helps us understand the level of thinking that students are required to use when answering test questions. Level 1 is the recall level, which involves basic remembering skills.
Examples from the test include defining a computer or identifying a device. These types of questions are dominant throughout the multiple choice items, which means most of the test required simple recall. Level 2 involves basic skills and concepts. Here, students need to show some understanding and make simple distinctions. An example is distinguishing between hardware and software. These questions were present on the test, but only in a minimal way. Level 3 requires strategic thinking. This level goes deeper, asking students to reason, explain, or justify. On the test, this appeared in the form of an essay on interdependence. However, this level only showed up once. Level 4 is extended thinking. This usually involves long term investigation, planning, or problem solving. This level was not represented at all in the test. Overall, the analysis showed that the test relied heavily on lower level cognitive skills, especially level 1 recall, with very few items requiring higher order thinking.
Okay, now we'll be looking at grammar, mechanics, and presentation. So the assessment showed several presentation strengths. One, instructions are generally clear and items use correct grammar. Two, the academic tone is appropriate for grade 7 learners. However, the assessment also showed, some weaknesses. One being inconsistent spacing, numbering, and section headings. This reduced, readability. Two, minor mechanical issues, such as punctuations and capitalizations errors are present. And three, the test layout lacks visual structure, including bolding and alignment, which may confuse candidates, and we don't want that, right? So, according to Nitko and Brookhart, 2014, professional presentations ensures fairness and minimize construct irrelevance variance. Okay, now we'll be looking at grammar, mechanics, and presentation. So the assessment showed several presentation strengths. One, instructions are generally clear and items use correct grammar. Two, the academics.
Thank you once again. So now we're going to go ahead into our recommendations for improvement. Following on the screen here, we have firstly the item construction. To improve this, you must revise stems for clarity and ensure distractors are plausible and grammatically consistent. The cognitive rigor. One must add application based or scenario questions to assess higher DOK levels. The rubric design. Create an analytical rubric for short answer and essay questions to improve scoring reliability. As for the presentation, one must use standardized fonts, numbering, and layout to enhance readability and professionalism. And as for the alignment, one must include more items assessing conceptual understanding and real-world ICT applications. So these are the recommendations we have for the traditional instrument. And just to brief everything once more, improve the destructor quality, add higher order questions, include psychomotor elements, use a rubric for the essay, standardized formatting, and ensure mark weighing matches the table of specification. I believe that once that is done, then students would be able to score higher based on how the instrument was created. Thank you once again. So now we're going to go ahead into or recommendations for improvement. Following on the screen here, we have firstly the item construction. To improve this, you must revise stems for clarity and ensure distractors are plausible and grammatically consistent. The cognitive rigor. Our recommendations are also grounded in the principle of Polfam 2017, Webb 1997, and Granlund and Bocart. These authors emphasize the importance of clarity, alignment, and diverse cognitive demand in creating valid assessments. Kristen will now summarize our overall evaluation. Thank you. The principle of Polfam 2017, Webb 1997, and
In conclusion or review of the traditional assessment instrument for grade 7 information technology, foundations of hardware and software has a developing understanding of assessment design principles. The use of multiple item types, coverage of key content areas, and inclusion of an answer key demonstrates awareness of objectivity, content coverage, and validity, and this is according to Nitschko and Bookhart 2014. However, several areas need improvement. Some items contain weak distractors and inconsistent phrasing, and while the objectives are represented, most questions target lower order thinking rather than deeper application or analysis. The assessment also focuses mainly on the cognitive domain, overlooking psychomotor and affective outcomes important in information technology. Additionally, minor grammar, formatting, and mark weighing issues reduce clarity and fairness, and this is according to Lin and Miller 2000. 2005. So we believe strengthening these areas would improve the instrument's overall validity and reliability.
This concludes our presentation. These are references. Thank you.